Hello everyone, we are from Group 1 Class 2A5A Semester 2. We'll be presenting our experiment on hydraulic jump under the supervision of Madam Nur Hidayah Binti Hamzah. The team members presenting today are Muhammad MUSTAQIM, Nur and ALEYA, Muhammad SYAZWAN, Muhammad IRFAN and Nur Shafiqah.
I will start with introduction first. A hydraulic jump is a phenomenon occurs when water flowing at a high velocity or known as supercritical flow that suddenly changes into a lower velocity that known as a subcritical flow, which will cause a rapid rise in the water surface. Therefore, a large amount of kinetic energy produced as turbulence during this process. Hydraulic jumps are often used in hydraulic engineering to reduce the flow energy and to prevent the erosion happens at the downstream structures such as open channels, spillways and sluice gates. So we explain about the objective of our experiment. There are multiple objectives to achieve in this experiment. So firstly is to observe the formation of hydraulic jump in an open channel. Secondly is to determine the flow characteristic before and after the hydraulic jump. Thirdly is to calculate the energy loss during the hydraulic jump. And finally to compare result between the theoretical and the actual result for the hydraulic jump.
The type of jump is characterized by Froude number at end section of rectangular flume, which is defined as follows. F1 equal to Vn over square root GHn equal to Q over BHn square root GHn. It will be found that the jump is characterized by a strong dissipative action. The specific energy upstream and downstream of the jump is calculated as follows. E equal to H plus V2 over 2G. The energy dissipated in the jump is given by Em equal to E1 minus E2. The power loss due to the jump in the rectangular flume can be estimated by PL equal to rho G Q Em. The condition which generate hydraulic jump are F1 greater equal 1.7 or F2 greater equal 0.6, where F1 and F2 represent the Froude number of the upstream and downstream flow respectively.
Next is about the problem statement. The high velocity of the water flow through the hydraulic structure can cause severe damage due to erosion happen if the energy is not properly controlled. Therefore, hydraulic jumps is an effective method because it will dissipate the excess flow energy before continue flow to downstream. By understanding the characteristic and behavior of hydraulic jump, it will be easy for designing safe and efficient hydraulic structures and minimizing the risk of the downstream damage.
The apparatus we use in this experiment is vernier caliper, rectangular flume, adjustable undershoot wheel, tailgates, hydraulic bench, and ruler.
First, turn on the machine switch. Next, adjust the position of the switch gate in the correct state. Then, place the tablet on the end of loop. Open the valve to release the water. After the water has come out, we measure the width of flume. Then, after water is stable, we measure the height of switch gate and Y. And then we also measure the height of Y1 is measured before the water jump, and then height of Y2 is also measured, and distance between water jump until the water is stable state. After everything is stable, we record the time and record the flow rate. All the steps are measured and repeat in 3 times.
Now I will explain about data and result. The data that we measure: width of the flume 0.088 meter, height of tailgate, volume, time, H, H1 and H2. The tailgate that we measure that we get is 1.9 meter. Volume we use 5000 ml and it's constant for 3 tests. And this is the time for 3 tests, H for 3 tests, H1 for 3 tests and H2 for 3 tests. Calculation. We must find V1 and V2. Firstly, we must find discharge. This is our discharge for 3 tests. and this is our V1 and V2. Second, we must find Froude number. This is the formula of Froude number. We just substitute the data that we have into this formula and we will get F1 and F2. This is our F1 for 3 tests and this is F2 for 3 tests. Lastly, we must calculate energy loss. This is energy loss formula. We must find E1 and E2 first. Using this formula, E1, using this formula, E equal to H plus V square over 2G, we get E1 and E2. After that, we use this formula for energy loss, E1 minus E2, and this is our result. Thank you.
Hydraulic jump is a phenomenon in hydraulic science which is often observed in open channel flows such as rivers and spillways. When the high-speed liquid is discharged into the lower velocity area, the liquid surface will rise quite suddenly. The fast-moving liquid suddenly slows down, increases in height, and converts some initial kinetic energy of the flow into an increase in potential energy, and some energy is irreversible, lost by heat due to turbulence. When the supercritical flow becomes a subcritical flow, hydraulic shock occurs. In this case, the height of the water surface suddenly increases in the direction of the water flow, and the sudden movement of the water flow is accompanied by a significant loss energy load due to the impact. The strength of the jump depends on the Froude number of the stream entering the jump. In conclusion, hydraulic jump experiments are a crucial tool for learning the physics of the physical process known as a hydraulic jump, which happens when a liquid like water flows over a fixed bed. Students can learn about hydraulic jump from the result of the experiment, and the information gained from it can be used to design weirs and spillways that are more effective and efficient hydraulic structures, as well as to better understand and control important environmental flows in rivers and natural channels.